MicroSeal is the base formulation. It's pressure activated at approximately 1,000 to 1,500 psi differential. It's used for the control line leaks, hydraulic system leaks, chemical injection lines, anything that requires a flexible seal. It's very thin, non-viscous, and very easy to apply. Okay, EnviroSeal is simply a modified version of MicroSeal. It's designed for activation pressures less than 1,000 psi. We can blend it to any system compatibility with an oil formulation, glycol, and or just a water-based fluid. Our primary oil is a hydraulic fluid. It's a control line. This is an oil-based control line fluid. We have glycol fluids as well. This is MicroSeal, just simply H fluid. And then we have surface chemistry modifiers, surfactants that adjust the parameters of the activation pressure and the set ranges for the MicroSeal and the EnviroSeal. Okay, we initiate a leak at 3,800 psi. Relatively large leak rate. Again, the injection pressure is 4,200 psi. Okay, we're going to shut the leak off, empty the chamber of water. Simply displace the water from the chamber to allow injection of sealant directly to the leak site then. Simply pour MicroSeal into the chamber and pump until it displaces to the leak. Okay, our injection pressure is 2,000 psi. We still have a leak, obviously coming down. It's not as diffused as it was. We'll simply increase the differential, and as the polymer enters the leak path, it begins to activate and seals the leak until the flow is nearly diminished. We now have 5,000 psi on the well, or on the leak. Shut it in, let the pressure bleed off, and then we'll cycle the pressure back up a series of times until we get the leak completely sealed. And we've got just under 6,000 psi on the leak. And we continue to cycle the pressure into it to force the polymer off into the end of the leak channel. Okay, the pressure's stable at 6,000. A little leak off, but we're going to continue to work the pressure up to 10,000. And we reestablished a slight flow through the leak, which is what was anticipated. We'll shut it in again, let it fall off as the polymer continues to seal off into the leak. Okay, we're at 10,400 psi, and just minimal leakage occurring now. Okay, we're holding 10,500 psi stable with the leak completely sealed. Okay, the leak is holding stable at 10,580 psi, so now we're going to cycle the pressure by bleeding it off rapidly and then applying rapid pressure back against the leak. Pressure's at 0, and then rapidly applied back to 10,000 with no problem across the leak. Again, back to 10,000, almost 10,750 now, with no leakage at the leak site. We'll cycle the pressure a couple times to ensure we get complete fibrillation into the leak path. The bleeding is to 0. And rapidly applying the pressure back to the leak. Again, right back to 10,600 with no leak off. At this point, we can consider it completely sealed. We shut it in 10,500, a little over 10.5. Okay, we will bleed the pressure off now, displace the sealant from the line, and then run water across the leak and repressurize it. Bleed the pressure to 0. Pump the sealant from the leak, or across the leak, no restriction whatsoever in the line. Sealant flows easily, the same consistency as when it was put in. Now we'll simply flush the rest of the sealant from the line with water. Okay, we're just applying pressure to the water to show that the seal is intact with the sealant out of the system. Through 8,000 with no problem. To 10,000, we shut it in. 10,000. And the leak is stable. The product, yeah, the way that the product is, what we just passed around is our base formulation, which is micro seal. Okay, we can modify it, we can put it in an oil, we can put it into a glycol, we can blend it so it's compatible with methanol, we can blend it to be compatible with anything. We essentially have, but the base formulation works about as good as any. It's very thin, very non-viscous compared to other formulations. We can make things thicker, but we plug by chemical rather than by viscosity. This is an oil-based solution, which is significantly thicker, used to generate more differential and a higher leak rate.
Okay,
So,
what is the difference in pressure now? 2,000?
Yeah, we've got 25, between 2375 and 2500 psi. We just simulated a control line fitting leak is what that is. What we've done is we've cut the threads so that there's a 1 millimeter slice in the threads, and then just tighten the ferrule on it just to contain it. That one right there is about 10 pounds per gallon. The base formula is 12 and a half. Yeah. Okay, I've got to displace the water from the line. Okay, there's this. Simply just pour the sealant in. It won't take very much to seal that leak. Okay. It was at 2,700 and it's down to 500 psi. So 2,200 psi in 10 seconds. Okay, we'll establish flow through the leak. You see the spray is beginning to be diminished as the sealant enters the leak path. It's all about establishing flow and getting differential pressure across the leak path though. Now we've got considerably reduced leak rate. We're at 4,800 on my gauge here. Just under 5,000 psi. Still have some, some leakage, and this is where what happens is you get it slowed down. Now we have to really work the seal to get it to seal off completely and totally so that we establish good fibrillation and a good total seal inside the leak. 5,600 psi. Just shut it in and let it fall down. And of course, in this small volume, it doesn't take but a drip to be, quite a bit of pressure. Okay, it's fallen off to 3,900 there. We'll run it it back up to 5. What we'll do is we'll just try to get the seal to establish, and it may break itself down in the process of it, which is okay if it does. Okay, now what I'm going to do is I'm going to hit it pretty hard, bleed the pressure off completely, and then here's the hose. Yeah. There we went from 0 to 6,000 pounds very rapidly, and the seal never, that's actually embedding the fibers inside of the leak path and embedding it. Sometimes you have to do that, sometimes you don't have to do it. It just depends on the final leak off. But yeah, there's still a little leak off, but it could be air in one of the valves even for that little volume. It's 5920, but we're going to work it on up to 10,000. Of course, in here we're limited, you know, by the size of our equipment, what we can do. I mean, this is obviously very slow. Our air compressors limited us to 9,600 PSI right now. The control line that we just did was a 3/8 inch control line in the Gulf of Mexico. It was a 19-mile tieback. We pumped into it at 1.25 gallons a minute and hit it, and it sealed off, and we took it to 15,000 PSI. So our limitations are, you know, about as high as your control lines are going to be. Casing leaks just depends upon what kind of leak you have. 11,500. So you can see the ability of it to withstand pressure once you get it to seal off, because what you're doing is you're actually filling in the leak path and you're creating a resistance to flow so it can't go anywhere else. So once you get it blocked off, once you hit it, you can just keep coming up with your pressure, and it's not going to go anywhere because it's going to be locked into the leak path, and it adheres to the actual leak channel itself. To actually repair a control line, you mean? How many times does that take? Of course, we can't bleed a control line off that fast. You know, this is very, you know, we can really bang this hard. Control line's you're gonna get a couple, you know, liter back or something like that. It just depends. So we'll probably we'll just cycle it as many times as we have to, but we won't be that violent with it. We just come up and we work it. You know, the limitations of the control line, obviously we don't want to make the leak worse. And like on the one we just did, we didn't even have, we bled the pressure down to 7,000 PSI, and that took about 15 gallons of material of control line fluid to do that, and then we pushed it back up, which takes some time to do it. So you just have to evaluate what you're doing. If you're doing an umbilical, or if it's a control line, or exactly what it is. But actually cycling the pressure 2 or 3 times is usually enough.
How about temperature? Do you have any?
Once the seal is set, temperature does not affect it. You can go, I mean, you're stable. You're going to be stable up to, you know, 600 degrees F, and beyond that actually. So temperature's not an issue. Cold water temperature, subsea, you know, as long as you don't have a situation where it's taking you a week to pump through it, you'll be okay. But what happens is the sealant, the molecular formula in it, stabilizes it in cold temperatures. So like if you refrigerate it, it will ruin the sealant because it just will remain just like that. It won't fibrillate. It doesn't have the properties of coming out of solution whenever at pressure differential.
What will happen with the remaining sealant in the control line?
It'll remain liquid, just like just like it is right there. It'll remain liquefied. And what I'll do is I'll displace this out, pressure it back up with water, and make sure that we've got a complete seal, because the sealant may still, you know, if there's something blocking it or something like that, but we want to make sure that we get a complete seal with water across it so that it's not sealant, you know.
The real situation will displace with the oil, oil, or just
depends what you have. Depends what you're doing. If you're doing a control line with oil, or if you've got synthetic fluid in it, or exactly what, we just displace with that. If the leak's real bad, we'll use a lot of volume. If the leak's relatively small, we'll just use a small volume, because the smaller the volume, what happens is, and it depends on where it's leaking. If you've got an insert valve that's leaking on the seals, you just want enough sealant to get in and cover the seals. You don't, because what will happen is after you get the seals repaired, then the valve wants to actuate. So then you get fluid entry into the valve, into the chamber, and then as it drives the piston down, you get sealant up in there, and then you create areas where you can create pressure differential and things like that. So you just have to evaluate it for what you have, so that obviously the primary concern is plugging a control line. anytime you pump something into a control line that's not control line fluid, there is an inherent risk. So you have to minimize the possibility of that happening. You do that by using minimal volumes, modifying the formulation depending upon what the situation is. If it's a fitting leak, which you can do with the diagnostics, you can pretty much tell if it's a fitting leak, if it's at the wellhead, if it's down subsea, or if it's in the seals. Different volumes. We'll just, different volumes, just pump volumes. But whenever you're only talking a 5 or 6 liter pump, a quarter liter a minute or whatever it is, it doesn't take that long to displace the fluid there. So, there's no point in putting the whole control line volume of fluid in and letting it sit there, because you'd rather have control line fluid in the control line, I would think, most of the time. So we just pump enough sealant to do the job and, leave minimal volumes in place. So that you...
Just make it
because it won't react unless it undergoes a pressure differential and experiences flow going through a leak path. It's just our personal preference to leave as little in there as possible, but anything that is in there is going to remain in a liquefied state and act just like your control line fluid. Well, it doesn't crystallize; it polymerizes, and we do have crystalline sealants. Our SEALMAKER casing repair system is a crystalline cementatious type sealant. This is a polymerizing sealant. The pressure differential, this one is set to activate at about 500 psi. It's higher; it's more viscous. The microseal that is right here requires about 1500 psi is its optimal set pressure. It'll go off earlier, but it just takes longer until you start narrowing the leak path down, so it takes more chemical. Well, yeah, but this is kind of the beauty of it. Case in point, the umbilical that we just did. What happened was we had a subsea leak on the hydraulic flying lead from the end of where the HFL connects to the SUDA and to the tree. And when they installed HFL, they damaged the connectors. They had good ROV footage of it. Well, 6 months later, they started leaking. Okay, and that's when we came in then. So we had, you're going into the HFL, which you've got monational coupling, which is less than a 1/4 inch ID with the poppet valve, ball valve, spring-loaded assembly in there, that we're going through 2 of those, one at each end of the HFL. And we had no restriction whatsoever inside of those in the check valves or in the CIDV valve. So, you do have, and we ran some pretty thick stuff in. And still had no problems with it or no restrictions. You always look for it, and you can always tell if you're prematurely plugging, and you can always flush the system and stop what you're doing right then and not get it to go to that point. It'll just plug the leak. En route to the leak, if you go through swedges or you go through different pressure areas inside the control line, as long as the system's pressurized and you've got complete flow through it and the whole system's pressurized, you're not going to create a significant differential pressure within. So the only place you're going to create the differential pressure is as it goes through the leak, and as it goes through the leak, you also have to have shear. Okay, so you have to have that violent shear of the chemical going through it to activate it. So that gives you the safety margin inside the control line. Yeah, this is just one scenario. We've demonstrated several different types of leaks: thread leaks, pinhole leaks. It just depends on what you have. As the leak diameter gets larger, it becomes harder and harder to number one, create differential pressure, but it becomes harder to span the leak as it gets bigger, just because you don't have you've got something that's flexible, so it can only go so big before it just flexes out. So it just but pinhole leaks, tubing leaks, thread leaks, things of that nature, it's perfect on. This gives you a flexible seal that's dynamic. It'll expand and contract inside of a safety valve. The insert seals, the valve can slide up and down and it'll stay intact. From stop to stop. So there's, it actually lubricates it. What happens, I don't know if you've seen the test we did with Schlumberger and Statoil, but after we pressurized the seals and when we released the pressure from the tubing, well, when we applied tubing pressure, of course it was locked in pretty tight. Well, it banged up against the stop and still maintained a complete total seal. But then when we relaxed the pressure on the tubing, it just slid back down to the bottom stop on its own. These are basically the control line fluids. Our casing repair line is, they're totally different fluids. They're clear fluids, like our surfactants are, relatively non-viscous, and they react upon the same concept of pressure differential and flow. However, it's a very slow process. This requires a very violent shear to get it to activate, whereas our crystalline sealants, which are comparable to cement, requires a very controlled, slow filtration process to allow the crystallization of the chemical from liquid to solid. Cost, it depends upon the leak, what type of leak you have. Obviously, leak rate, it typically requires more sealant, and it's pretty much based on leak rate or leak type. These sealants are like a control line. A standard cost is going to be for the sealant application, but
I'll just give you an example. For 2 control lines, the cost would be Malaysian ringgit around 340. Ringgit. 1,000 ringgit. Not ringgit. 1,000 ringgit. 340 to 360
for 2.
For 2.
So it's 180.
Yeah, 180, 190 per normal control line leak.
And that includes the sealant application, get bubble.
Too much.
Actually, on response to that, we have our international, one of our agents already compared. We have a competitive price. That one that we just explained just now, for 2 control line leaks, 340 to 160, or 1 control line leak, 180 to 190, is actually inclusive of the mobilization, mob and demob, the diagnostics.
What we do in the case of when you talk about longevity and lifespan of a leak and a leak repair, we work together with you guys. Okay, so if I leave the platform and the thing starts leaking for some reason, I'm going to go right back and get it fixed up for you. If we're sitting there, 2 months into the future, and oh yeah, we've cycled the pressure, to 15,000 psi. We bled it. If we've done something, that's created a bad situation, then we would feel like we weren't obligated to honor, to have to come back and redo it if it was something that was done, even if it was inadvertently or anything like that. But the important thing is we work together. We're not here just trying to pump sealant and get an invoice in the mail. We're here to fix problems, and that's where we come from. And we've got 15 years of experience doing this, and you can talk to any one of my customers, and they will stand behind how I do business and how I treat my customers. The primary difference between the microseal is the base formulation. When we modify the sealant to make it do different things, we simply change the name to EnviroSeal for MSDS purposes, or to EnviroSeal for MSDS purposes. Simply has typically a higher surfactant content or various composition, whether it's glycol or oil content. It's just the modified version of microseal, and it typically allows it to set at lower pressure differentials or create some restriction to flow to create some pressure differential. EnviroPlug is a totally different sealant. That is a high density weighted fluid that we use primarily on packer leaks, that we pour into an annulus or apply into an annulus, allow it to migrate down. It weighs about 16.5 pounds per gallon, and it will retain its original characteristics once it goes back into, once it settles at the bottom. It's more of a grouting material. Tubing leak, we're typically going to use the EnviroSeal or the MicroSeal, just because you get a flexible seal that's going to expand and contract with the tubing. So it's going to change dynamically with the situation. We can use our SEALMAKER technology on it. It's crystalline, but it's rigid. So as the tubing expands and contracts, you're probably going to get degradation of the seal across the leak path. Yeah, you're better off with the crystalline sealant. This will react synergistically with our SEALMAKER system, and we get some good chemical reaction between them. That works synergistically whenever it enters into a formation. So it allows us to, we do a lot of work in the United States and New Mexico, primarily plugging off perforations and casing leaks using this product, and we've had about a 100% success rate. We've done over 30 wells and we've had 1 failure, so 90-some percent. Yeah, in certain cases, you have to evaluate the formation. A lot of times I don't know what the formations are like here, so I can't say that it's going to work here. But domestically in the United States. We do it all over the country, and we've had really good success with it. Where you have problems is when you've got very, very thick zones with a lot of water drive and a lot of pressure. Yeah, obviously it's a function of the leak rate as to how long it's going to take to displace it. We do bulkheads literally every single day, large casing diameters. It just, it's a function of the leak rate is how long it's going to take to get it into the well and get it down to where the leak is. It's heavy. Our SEALMAKER system is about 10.5 pounds per gallon, so it typically displaces through your annular fluids, typical brines. You can actually use the gas lift valve a little bit to help get you down. You just have to look at how the wellbore is constructed and if there's anything to use. If you're going on like the B annulus where there's absolutely no, your closed system, then you have no option but to bullhead down, and that's just a function of the time and the casing leak rate, the leak rate. You can actually create sealing in three different ways on a casing leak. You can actually seal the formation, plug the formation, create a formation barrier or a block. Just by crystallization, by permeability of the zone, creates the filtering medium and allows the crystallization to occur in the formation. You can also get it to occur as it goes through a tight casing leak. You can get reaction there, and then you get deposition and a buildup similar to a cement column in the backside, which gives you plugging. Or then if you've seen our video of the subsea pipeline repair, you actually can get crystallization across the leak path and actually adhere to the backside of the casing itself. So you can get three different areas where you can plug. Which one happens, I don't know. But those are the three that I visualize in my mind as the three ways that it works.